Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and we are on the wrong slide. We are on the last slide. We are actually going to solve some radical equations and inequalities today. So if you're looking at this, this is likely an Algebra 2 topic that's covered throughout most of the US, I think. But without further ado, we're going to go ahead and we're going to take a look at how to solve these types of radical equations. And hopefully you can use the tools that I give you in this video to go ahead and apply that to other problems as well. So as with solving any type of equation, we know that we are going to isolate the variable. But with these radical equations here, our goal is going to be to isolate the radical first, then go ahead and remove the radical and then solve the equation the way that we've learned in any of the past years that we've covered solving equations in math, okay? So without further ado, we're going to get started with this one. So in order for me to eliminate the radical first has to be on its own. So it is on its own here. And we know that this radical is actually kind of like to the 1/2 power. So to make this portion right here, this 5x plus 1 to the first power, we're going to take this 1/2 and square it. So, right, half of 2 is 1. So I'm going to take this portion and square that. And I'm going to take this portion and square that as well. And so I'm going to be left with this 5x plus 1, because the squared and the radical will kind of cancel each other out, equals 36. And then I'm going to subtract 1, solve like a regular two-step equation. You probably covered this in middle school, and then x is going to be 7. Now, one of the things that I do want to emphasize here is that we will likely want to check to make sure that our answer is actually appropriate for this problem. So we will go back and we will do 5 times 7 plus 1. We'll get 35 plus 1, 36, and the square root of 36 is indeed 6. So it does work out. So 7 is a solution. Okay, the next one, the radical is not isolated. So we're going to actually have to isolate this radical first and then go ahead and eliminate the radical. So the first thing I'm going to do is I'm going to add 15 to both sides. I'm going to be left with 8, and then the third root of 10x is 32. Divide both sides by 8, be left with the third root of 10x is 4. Then, because I'm looking at the cube root of this radical, I'm instead of squaring this, I'm going to cube this. So I'm going to end up with 10x is 64. Divide both sides by 10, x is 6.4. Now, I've done these problems in the past, so I know that this is actually going to be a solution. But on your end, I would recommend definitely going through and checking to make sure that this is whatever solution you get, that it actually is the proper solution to this problem. Okay, so now in this case, my radical is actually isolated, and it doesn't matter. I know lots of students in the past have asked me, does it matter where my radical is if it's on the left-hand side, the right-hand side? It does not matter at all. So long as it's isolated, right? So like if I had a +3 over here, it's not isolated, I would move that +3 over to the other side. So what I'm going to do in this case is I'm going to take both sides of my radical and square them. And because this is an x minus 6 squared, that's like me having two sets of parentheses of x minus 6 and x minus 6. And then here my radical and my squared will eliminate. So I'm going to end up with 3x. Here I'm going to end up with 2x minus 12x plus 36. All I did was multiple distribution or FOIL, whichever method you prefer, or not whichever method, but whichever term you prefer for that same method. I'm going to go ahead and subtract 3x. So I'm going to have x squared minus 15x plus 36 is 0. Now my factors of, so I'm going to have to factor this out. My factors of 36 are 1 and 36, 2 and 18, 3 and 12. And it seems to me like 3 and 12 would be the best match. So I'm then going to go ahead and do x minus 3, x minus 12. Both of them set equal to 0. X would be 3 and x would be 12. Again, I'm going to go ahead and I'm going to try both of them out just to make sure. So regardless of how many solutions we have, we're going to go ahead and plug both of them back in each individually. So I'm going to end up with 3 minus 6, and that equals -3. And does that equal the root of 3 times 3, which is regular 3? And since that doesn't really equal to each other, then I know that x equals 3 is an extraneous solution. So then I'm going to check the other one. Now, 99.99999% of the time, this is going to work. But, I mean, who knows? Maybe you did the math wrong somewhere and it's not really 12, it's maybe 11. I would still go back and check it just because we want to make sure that A, we have the right answer, and B, we don't have any extraneous solutions in our proper answer. So in this case, I'm going to end up with 6 and then root 36. And since they do equal each other, I know that x has to be 12. Okay, so we're going to move on to similar types. And in this case, since my radical is again all by itself, we're going to go ahead and we're going to cube this. And the only reason why we're going to cube it is because we have a third power, right? Or sorry, a third root. So I'm going to go ahead and third root that. This third root is going to get canceled by the cube. And I'm going to be left with this, whatever's inside the radical. And then this is going to have to be multiplied out. So you're going to end up with 2x minus 1, again 2x minus 1. Oops, sorry. My pen got messed up a little. And then again 2x minus 1. So I'm going to FOIL this out, and then whatever I get from foiling these out, I'm going to then distribute it to that, to this entire parenthesis. Now, I've already done this math before, and just to make things move a little quicker, I'm going to copy it down from my screen ahead of time. Okay, and then, so now I can go ahead and I can solve this. So I know that I can subtract 8x cubed from both sides and add 1 to both sides. So these guys will cancel, and I'm going to be left with -12x squared plus 6x equals 0. In this case, I can factor out -6x and be left with 2x, oops, not plus, minus 1 is 0. Set each of these parentheses equal to 0, just like you would in any normal factoring problem. You'd get x is 0, and then in here you'd get 2x minus 1 is 0, so 2x is 1, so then x is 1/2. We will go ahead and we will check both of them just to make sure that both of them are actually accurate. So I'm going to take 8 times 0 to the third power minus 1, and then I'm going to take the cube root of that. Well, this just ends up being nothing, so the cube root of -1 is -1. And does that equal 2 times -1 minus 1? Well, this gives me -2. -2 minus 1 is actually, oh, whoops, sorry. That was not correct. I needed a 0 in here. So then this actually also cancels out, and then I'm left with -1. I got distracted by this -1 and this -1. There's too many -1s, guys. It's too much. So since both of these equal each other, then great, this answer totally works. So let's see if we can see if 1/2 works. So I'm going to take 8 and multiply it by 1/2. Whoops, that's what we're looking to the 3rd power. So 8, that would be 8 times 1/8, because 2 to the 3rd is 8. Basically 1 minus 1 is 0. The cube root of 0 is 0. Then I'm going to do 2 times 1/2 minus 1. So half of 2 is 1. 1 minus 1 is 0. Actually, they do equal each other. So then this is also a solution. So a couple things here. In the previous problem we had, we did have an extraneous solution, and we did have a actual solution. So in this case, there was only one solution available to us. In this case, both solutions actually worked out. So it happens to be sometimes that both work out, sometimes only one works out. It just depends on the type of problem. Okay, so in this particular case, since our radicals are not on separate sides, what we're going to do is we're going to actually put them separate. So I'm going to add this cube root of 8x plus 1 to both sides. And I feel like I did not leave myself enough room for this math problem, so I might actually have to erase this. We'll see. So now I have the cube root of 2x minus 5 is equal to the cube root of 8x plus 1. Now, something that you'll notice is both of these are cube roots. So if I cube both of them, I'm going to actually eliminate the cubes. So I'm going to end up with 2x minus 5 equals 8x plus 1. And then this is your basic multi-step equation with variables on both sides. Probably something that you covered in middle school. Totally acceptable for an Algebra 1 student. And here we go. So we're going to end up with x is -1. And then again, I absolutely want to make sure that I check this, right? So 2 times -1 minus 5. So I'm at -2 minus 5, so -7. Cube root of -7 is who knows? We actually don't even care. So long as we know that this other one will also be -7 so that I can subtract it, right? So I'm going to subtract 8 times -1 plus 1. So this will be -8 plus 1, which is also -7. So I'm going to end up with the cube root of -7 minus the cube root of 7. Does that equal 0? Yes, it does. Correct answer. Again, we really do want to make sure that our solutions work. There's so much work that goes into it. I mean, if you take a look at just number 4 on its own, even number 5, you've got multiple steps that you're using to solve this problem. If you're putting in the work and putting in the effort to solve the problem, why not check to make sure if it's correct, right? Because the worst thing would be is if you feel super confident and the answer is wrong, and you're on your test and you're like, ugh, why me, you know? So you don't want to be that kiddo who's in that position. You definitely want to go in and check things out. Okay, so the other two types of equations that we have in this particular video, we're going to talk about what happens when we have fraction exponents and what happens when we have inequalities. So the fraction exponents, nothing changes. We want to get the fraction exponent on its own, that term on its own, right? So in this case, I'm going to go ahead and I'm going to subtract 3 on both sides. And I'm going to end up with 1/4, x to the 1/4 power is -3. And then in order to eliminate this fraction exponent, I'm going to actually put it to the 4th power because 1/4 of 4 is 1. And then I'm going to put this side also to the 4th power. Now I know that -3 or 3 to the 4th power is 81. And then that's going to be my final answer. Normally, I don't check questions that are this basic, but again, I've been doing this for quite some time, so I know kind of like where things are. If you feel confident enough, definitely go for it. But if you're starting out and you're still struggling with these types of problems, keep up the work with checking your answer. It's super, super important. Okay. So again, in this case, because this is to the 1/2 power, all I'm going to do is multiply by 2. Now, sometimes I get questions like, Anna, why is it 2? Why is it 4? Why is it 3? Why can't it just always be consistent? Well, really, all we're looking for is an exponent to be 1, right? So if I were to multiply these two, I'm kind of doing that reciprocal, right? So because I'm multiplying by a reciprocal, I'm going to be able to get that one pair, right? So this kind of like cancels each other out. So I'm going to be left with x plus 6 on this side, and then I'm going to square this, and I'm going to end up with x squared here. Now, something that you'll notice is anytime I have an x squared, I'm likely going to have this method of factoring, right? So I'm going to go in and I'm going to subtract both of these on this side. I could have subtracted the other side, but then I'd be left with a negative x squared, and I don't want to deal with that nonsense because ain't nobody got time for that. So now I'm left with x squared minus x minus 6, 0. Go in and factor, make sure that we're factoring appropriately, right? So x and x, my factors of 6 are 1 and 6, 2 and 3. I really love keeping these guys on the side just so that I can see what I'm working with here, especially with the bigger numbers, so that I'm not sitting there thinking, oh, did I think about that one? Did I not? So I'm going to choose 2 and 3 because I think that those will be my best options. I know I want a -1, so -3 and +2 inside the parentheses. And then when I set each of these equal to 0, I'm going to end up with -2 and +3. So now I'm going to go in and I'm going to go ahead and I'm going to check those answers, right? So let's see if these guys work out. So I'm going to end up with -2 plus 6 to the 1/2 power. That looks like 112. Okay. So that's going to end up being 4. 4 to the 1/2 power is the same thing as square root of 4, which is 2. And then if I take -2 to the 2nd power, is that going to be 2? No, it's actually going to be 4. So those do not equal each other. So this is going to be a rejected solution. And then I'm going to go ahead and I'm going to take this 3. So I'm going to actually use this space here. So 3 plus 6 is 9. 9 to the 1/2 power, or the square root of 9, is going to be 3. So let's see if that works out. Does 3, oh my goodness, I'm so silly. I didn't need to square that because the original equation didn't have that squared. So meaning, well, actually, I don't think it's going to work anyway. 2 does not equal -2, so wah, 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 that's rejected. And so then in here, since it equals x, 3 does indeed equal 3. So ta-da, this is an actual solution. Another thing you want to keep in mind is, are you using the proper original equation, right? So definitely make sure that you're underlining or highlighting or keeping tabs on where the original equation is. Maybe don't mess with the original equation like I did in problem 7, to make sure that you're not like, oh yeah, this is totally rejected, and then maybe reject an answer that should not be rejected, right? So luckily I caught myself, but in case you didn't, or if in case you don't, it might be a good idea to rewrite the problem. and use the rewritten problem. Okay, so the rules from all the previous 7 problems still apply. We still want to get the radical on its own. So in order to do that, I'm going to go ahead, I'm going to add 5 to both sides. And I'm going to end up with 2 root 3 of x is greater than or equal to 8. Then I'm going to go ahead and divide by 2 on both sides. So now I'm looking at the cube root of x is greater than or equal to 4. And I want to make sure that I did this math correctly. Okay, yes, I for sure did. Okay, and then we're going to go ahead and we're going to cube both sides. When I cube both sides, these guys go away. Then I'm going to say that x is greater than or equal to 64. Again, in this case, we definitely want to make sure that this is a number that will work out. And in fact, it does. There are other types of problems where you will need to make sure that you find a lower number and an upper number. Okay, so let's go ahead and we'll check that out. So let's go ahead and let's take a look at this. So I know I need to get my radical on its own. We're going to divide both sides by 4. I'm going to end up with x minus 2 is greater than 5. I'm then going to go ahead and square both sides. So I have x minus 2, where the radical and the square cancel each other out, is greater than 25. Add 2 to both sides. And I'm left with x is greater than 27. Now, before I say that this is my final answer, I kind of have to do another check, right? And that's kind of what I was talking about in problem 8. So when I look at this, I say, yes, this is absolutely 100% correct. Anything that's greater than 27 is going to be an answer to this problem. But I also want to make sure that this is not a negative number, because if it is a negative number, then my answer will be imaginary. So what I'm going to do is I'm going to actually take this, x minus 2, and make sure that that's greater than or equal to 0. Okay. And so in this particular case, I know that x is going to be greater than or equal to positive 2 because I add 2 to both sides. Now, on my number line, when I go in to graph something like this, 2 is here. I'm going to have a closed circle, and I'm going to have an arrow pointing this way. 27 is here, let's say, and I'm going to have an open circle with an arrow pointing this way. Now, if I were to look at this x is greater than or equal to 2, I know that that includes this particular solution. And this particular solution includes part of this solution here. So what I'm going to do is I'm going to incorporate just this solution as my final solution. Because if I put in a different number, so let's say I put in, I don't know, 11, right? So 11 works here. So let's go ahead and let's put 11 in. So I have 4, and then 11 minus 2, and then greater than, okay, beautiful. So I'm going to end up with 4 root 9 is greater than 20. Root 9 is 3, so 4 times 3 is greater than 20. 12, in fact, is not greater than 20. Since that doesn't work, this portion of the solution will not work, and only this x is greater than 27 will be the only part of the solution that does work. Okay. Let's take a look at what happens when you have more than one piece of a solution that will work. So again, my radical is not on its own. I'm going to go ahead and make it on its own. So I'm going to subtract 3 from both sides, 2, and then square root, and then I'm going to end up with 5, and then divide by 2. So square root x is less than 5 over 2. I'm going to square both sides to eliminate the radical. X is less than or equal to 25 over 4. Okay, So this is one piece of my solution. 25 over 4 is 6 and 1/4. So x is less than or equal to 6 and a quarter. All right. So now let's go ahead and let's take a look at what's inside of my radicand. So in here, it's just x, and we know that that has to be greater than or equal to 0. So let's see what happens when we graph it. So I've got 0 in here, and I've got 6 and a quarter here. Oops. In 6 and a quarter, I'm going to have a closed circle with an arrow pointing in that direction. With 0, I'm going to have an also a closed circle with an arrow pointing in that direction. So all of these numbers are going to be included in my solution, meaning I can't put any negative numbers, because if I do, my radicand is going to be a negative number, and then I'm going to end up with an imaginary solution. And I can't put anything above it because my answer says no thanks. It doesn't work out that way. So my final answer is going to be a combination of these two. I'm going to say that 0 is less than or equal to x, which is less than or equal to 6 and a quarter. Again, a few things. We want to make sure that we're eliminating everything from the radical, leaving the radical alone on one side. Then eliminating the radical by multiplying the exponent by the reciprocal. Then we're going to do all the steps that we know how to do to solve equations in the past. And then we want to make sure that we're checking our solution. Checking your solution in this particular case is going to be super important, and I can't stress enough how important it is. Okay, so I will see you around in another video, and happy studying.